Assalamu alaikum. This is Muhammad Daniel Lidar Zuhaifa from CSE 427 Section 5, and we are here. And this is
I'm his teammate. I'm Raisul Islam from Group 5.
okay. So today we are going to demonstrate our project, and our topic was basically predicting the groundwater level from a district Godagari, and as features we have implemented the deep tubal counts, the shallow tubal counts, and we have here I can show you. Let's show you. We have evaporation. We have taken a weekly figure, and same goes for rainfall as well, which have later been modified into a lagged column for a better prediction score. So our target is groundwater level, and the way we approached was, at first we just put a test of Godagari 1. So there are like 12 locations of Godagari. All these individual locations have individual sheets, individual data sets, and we have run models on all of them sequentially, and to see how the groundwater level is actually fluctuating over the years. So if we see our report, we have done, obviously natural data is not all good, and you have to process that. So we used the statistical language R programming for handling values and taking them into duration that applies to all the columns. For example, making them from daily to weekly, and also using Python pandas library for data manipulation and handling missing values and duplications. And later on, we have discovered the groundwater level and introduced the rainfall lagged column. And since we have installed rainfall lagged column, the score was still pretty low. The models were showing in a negative value. The score was negative for GRU, LSTM, XGBoost, and all of them. So we researched how we can improve this, and we found out that we can introduce a groundwater lagged column, since rainfall and these other features, although they are contributing, but they are not exactly correlating with each other in order to actually predict a groundwater level data. So when we introduced groundwater level as a lagged column, the whole model was depending on that singular column and was ignoring the other features. So what we then did was research further about the domain, how to improve, how does the groundwater actually fluctuate, and what mathematical approach can we take to optimize our models in order to achieve that. So my friend Raisul Islam, he actually found out a few very good ideas, and he will now talk about them.
So in the figure 3 and figure 3, you can see that the LSTM score is very low. It is basically in the negative. Then what he did was we added the groundwater level lagging, and it showed that the result was very improved. The problem was it was using only the DWL column. If you see the code, we tried different methods. First, what we did was we ran the models on the raw data, and the result was on the negative. And then we tried different methods. We added cyclic.
You can have to scroll a little bit below for that.
Okay. What we did was we added cyclic time features. So if we describe a little, the model sees the time series data as a linear. So there is when the distance between month 1 and the month 2 is only 1, but when the model sees January and December, it treats as a 12, but the difference between December and January is only 1 month. So we try to plot it in the graph. As you can see, this time series, what it does is it it shows a circular. It's creates a wave using sine and cosine, and that implements in the yearly basis. And again, so what did we do? We tried to remove the feature cheating. Basically, it was using only one feature. So we added the
Let's take a little time to find it out.
okay. So in Godavari 1, what we did was we added the regularization and delta reconstruction. What it did was we added dropout 0.2. So what it does, it doesn't let the model run basis on the only one feature. It forces the feature to go off and other features to perform as well. So if you check, and here the feature uses is importance is pretty much not actually not like that before. That was when we see that GW lag was using 0.9. হোল আমার 0.9 ওটা কই গ্রাফটা কই হোল ওটা কই
কি বেটা নষ্ট করে দিলি বেটা
আরে ওটা কাট করে দিব না চাপ নাই 0.9 ওটা কই এটা
কিসের 0.9 কোথায়
জিডব্লিউ ল্যাগের ওটা ভিতরে একটা ছিল যে গ্রাফ
এই যে
আচ্ছা জিডব্লিউ ইউজ করছি না ল্যাগের
হ্যাঁ হ্যাঁ এর উপরে
এই যে
হ্যাঁ এডিট করা লাগবে এখন আবার ভিডিওটা
আমি এডিট করে দিয়েছি তো পেলে চিকেন দিব ওটা এডিটর ওটা বসে আছে ওকে ওকে ঠিক আছে okay here you can see the rainfall using the almost all the feature importance. It has almost 9.98%, 98%. So after feature engineering, we reduced the cheating and it is almost using 0.25, which is in model training is pretty good. So after that our result increased. Our result actually, you can see the actual and the predicted graph, which is in negative before, and now it's in the positive side, and it's pretty close. It means the models are performing really well in these conditions. So we found this, and then what we did was we ran this model with this feature engineering for all the other CSV files, and as you have the 12 CSV files for different 12 locations, and then we try to compare the models as which model is doing good and which area has the better results. And as you can see in the compare column, and my friend will describe now.
So we can see actually combined graph here that shows all the 12 locations in Godavari, and we can also see which model is performing how is their performance score, and the high accuracy threshold has been set as 0.9 something. So what this actually shows is, although we have tried to optimize the model for a single district, single upazila, which is Godavari, however, due to some constraints, the model is not performing well at all for some locations. For example, if we check for Godavari 4, Godavari 4 has a very it still has a negative score, and we are actually we have come to the conclusion that due to some lackings of more features and some other technologies, these cannot be improved by what we have now. So this is our project, and we are hoping that if we could take more data, for example, vegetations of those areas, or soil properties, and some more feature columns, and I think we can optimize the model more efficiently. So that's all for our project, and okay.
All the models are working pretty close.
So all the models are working pretty close, so that's good. And yeah, so thank you everyone. This has been all I want to say, that this model has been done with our feet and sweat, and all the data sets are actually taken from the government, and this is actually a very water stressed region in our country, and all of the data are actually raw data that we have processed and trained the model. So thank you everyone.